Now that we have a little bit of an idea of how to do inequalities and what set builder notation is, let's see if we can't do a little bit of practice. The first problem says y minus 18 is less than or equal to negative 4. And so this looks like a really simple thing. All we do is we add 18 to both sides. Those cancel there, and then y is less than or equal to 18 plus 4 is 14. So we find a positive 14 somewhere in between here, and we see that y is going to be less than that. So wherever 14 is, we will go, that's probably one of the worst bits of shading I've ever done, but I think you get the point there. Y is less than 14. All right, let's just leave that one alone and go to the next one. This one says that 2/3 of x is greater than the quantity 2. Now, by the multiplication principle, all we need to do is multiply by the reciprocal, multiply this one by the reciprocal, and those will cancel, and those will cancel, leaving me with only x being greater than, those will cancel, 3. So here's 3, and since we're not going to include the 3, we're going to put a little rounded parentheses there, and x is greater than that. So that's how we will do it with graphing. Let's take a look at a couple of examples using interval notation. This one says the opposite of 1/8 of y is less than or equal to negative 9/8. And let's go ahead and apply that same multiplication principle, and we're going to multiply by a negative 8 over 1, a negative 8 over 1. And because we multiplied by a negative, we have to flip our inequality. Even if our product was negative, that isn't what matters. What matters is that we are multiplying by this negative 8 there. Those will cancel, and I'll be left with a negative times a negative is a positive y. That's the whole thing. That's the whole point of what we did. And those will cancel, and a negative times a negative is a positive 9. So now we need to use interval notation to explain that y is greater than or equal to negative 9. Now remember, interval notation either has one of these symbols, and we want the minimum, comma, the other of those symbols, and it depends on what our number includes or doesn't include, and the maximum. So the minimum in this case is our negative 9, right? That's the smallest number in our interval, and because it includes, we will use which bracket? If you answered square bracket, you are correct, comma. What's the maximum of our expression here? Well, any number greater than 9 goes all the way to a positive infinity, and anytime we reference infinity, we use a parenthesis. Let's take a look at one more example. And this one has a few more steps, so let's go ahead and just do it right where it is. This one has fractions in it, and we don't really like fractions all that much, but we can deal with fractions since the fractions already have the same denominator. Let's take the whole thing and multiply it by that denominator. And it's positive, so we don't have to worry about flipping our inequality at this point. So 12 times 5x is a 60x. It's a nice and big number. Negative 1/12 times 12 is a negative 1, so 60x minus 1 is less than or equal to 12 times 5 over 12 is 5, because those 12s cancel. 12 times 4 is a plus 48x. Now we just use our tools to solve. We'll subtract 48x from both sides, add 1 to both sides, right? Since we're moving the x's essentially over from here to here, let's go ahead and take the whole numbers and move them from here to here. So to do that, we will say those cancel, and 5 plus 1 is 6, greater than or equal to. 60 minus 48 is 12x. and those cancel. So now we can divide by 12 both sides, and we get x is less than or equal to 6 over 12 is 1/2. So we'll say 1/2. Okay, now how do we write that in interval notation? Well, since we're going smaller all the way to a negative infinity, then that is the minimum of our interval. The smallest number we can use is a negative infinity. The biggest number we can use to have a true statement up here is 1/2, and it includes that 1/2 because it's less than or equal to, so we will close it with a square bracket.